So this is about relative velocity. Let me give an introduction of relative velocity. Okay, the best thing to understand relative velocity is two trains when they are traveling in the same direction. You literally see the person of the other train sitting, eating there, or whatever, which means it will be going very slowly. Why? Because let's consider this train to be A train and that to be B train, and A and B has got velocity VA and VB. Velocity of A with respect to B is actually VA minus VB, and this is also in positive direction, it's also in positive direction, so then therefore the net velocity decreases. Okay, so actually the velocity of A, supposing this is going at a speed of 50 kilometer per hour, it's going at a speed of 45 kilometer per hour. Okay, but both of them are going like almost same velocity, so it will appear to be going very slowly. 50 minus 45 is 5 kilometer per hour. For that fellow, this will appear to go at 5 kilometer per hour, not 50. Okay, so then that's the relative velocity of one with respect to other. So velocity of A with respect to B is VA minus VB. So in the case of train which is going in the opposite direction, VA is okay. So let's consider VA to be positive. VB is going in the negative direction, correct? So when we are doing VAB, which is VA minus, it will become minus VB. So it will become VA plus VB. That explains why when the train are going in opposite direction, it goes so fast. Like that it goes. Okay, that's because the velocities are getting added in that, and that's what is relative velocity mean. Okay, so sometimes, okay, let's do some sums and understand the concept. Okay, example 43. Example 43. Page number 3.34 in Aurora, a car A is moving 10 meter per second on a straight road is ahead of car B. So the car B is here and the car A is here. The car A is moving at a speed of 10 meter per second on a straight road, is ahead of B in the same direction. This is going at a speed of 6 meter per second. 6 meter per second. Find the velocity of A relative to B. So velocity of A with relative to B is VA minus VB. Both of them are in positive direction. So VA is 10, VB is 6. So 4 meter per second is the relative velocity of A with respect to B. A with respect to, if you're sitting in A and you're looking at B, that's what it means. Relative velocity of A, no. The velocity of A with respect to B. So you're sitting at B and observing A. I hope you understood. So then velocity of B with respect to A will be VB minus VA. VB itself is 6, VA is 10, so minus 4. So if you're looking at sitting on A and looking at B, obviously it is negative because it's coming slowly. It is appearing to come slowly, so that represents minus 4. Negative velocity indicates the driver of car A sees the car B lagging behind. That's what it means. So let's go to 44th question. Two parallel rail tracks run north to south. Train A moves north. So north to south is this, okay? That's north and this is south. A train A is moving north with a speed of 54 kilometer per hour. You want to convert to meter per second, it's 5 by 18. 18 threes are, so it's 15 meter per second. And the train B is moving towards south with the speed of 90 kilometer per hour, and which is into 5 by 18, and 18 fives are 90, so 25 meter per second, and that's going in this direction. What is the relative velocity of B? This is train B, okay? Relative velocity of B with respect to A, as you know, is VB minus VA. The one which is going in upward direction, that's north direction, if I'm taking as positive, what is going down, I will be taking it as negative. So V upward is 15, VB is downward, so minus 25, minus VA is upward, which is 15, so minus 20 meter per second. And it's very obvious that's going to be added because they're going in the opposite direction. So it makes sense. That's V of B with respect to A. Okay, so that's B with respect to A, they're saying 25 minus 15. What did I say? I wrote it wrongly. I considered it as VB. VB is actually 25 and it's downward minus 25 minus 15. I'm sorry. I hope you understood. So then therefore it is minus 40 meter per second. Now next part of that's the first subdivision. The second subdivision is relative velocity of the ground with respect to B. See, when you are traveling in the train, the ground will appear to move in the opposite direction, but it's only appearing to move. The ground is really not moving. The real ground velocity is always zero. Vg is zero. So it's Vg minus Vb, where Vg is always zero. Okay, the relative velocity of the ground with respect to B. What is the B car's velocity is minus 25. So minus 25. So that will give me plus 25 and that will be the relative velocity of ground with respect to B. So that's plus 25 meter per second. So the third subdivision is the velocity of the monkey running on the roof of the train A. So then on the train A, there's a monkey which is going to be running in the opposite direction. The train A, while it's moving in this direction, the monkey is going to be moving in opposite direction. Okay, against the motion. And the relative velocity, they've given that with the velocity of 18 km per hour with respect to train. So velocity of the monkey with respect to train is what is 18 km per hour into 5 by 18 will make it a 5 meter per second. The 5 meter per second is the relative velocity of the monkey with respect to the train. Okay, what are they asking? They're asking um, uh, what is the velocity of the monkey? The exact velocity of the monkey. Velocity of the monkey with respect to train is velocity of the monkey minus velocity of the train. The relative velocity is given as phi. Velocity of the monkey is Vm. Velocity of the train, as you see, this is a which train is it? The train A, right? So right, train A. The train A is going with positive answer, which is plus 15. So the velocity of the monkey. Okay, here is where I have a problem. When I write this relative velocity, I should not write plus 5 here. I should write minus 5. Why should I write minus 5? Because the relative velocity of monkey with respect to A. So a person sitting in the train A is looking at the monkey going in the opposite direction to the train A. So the relative velocity should be set as small.